The worldwide consumption of paper and board today is approximately 345 million tons per year. Almost half of it is printing and writing paper, such as newspapers and magazines, which are returned as recycled fibers to the paper-making process. This animation describes the various stages in the de-inking process, which transforms recovered printing and writing paper into new reusable fibers. To show the actual process more clearly, we have arranged the main process machines in a straight line and excluded all pumps and pipework from the animation. The recovered paper is delivered in both loose and bale form. The bales are automatically dewired and broken up in a bale opener, and then conveyed together with loose paper into a pulping drum. In the pulping drum, the paper is mixed with water and additives, and gently broken down into individual fibers at the highest possible consistency. Caustic soda is added to enhance the release of printing ink from the fibers. This mixture of fibers, water, and additives is called stock. Before the stock enters the following screen drum, additional water is added to wash off the fibers from the contaminants. The fibers are collected in an accepts trough, while the large contaminants are held back and continuously removed from the system. Some small contaminants pass through the 6 to 8 millimeter holes in the screen drum and are removed in a high consistency cleaner using centrifugal force and gravity. In this case, a two-stage protector system increases the removal efficiency of the heavy contaminants and also improves operating reliability. Now, the first stage in screening starts: the removal of lightweight contaminants with a flat shape, such as plastic foils and polystyrene. For this, the fiber stock has to pass through a screen basket perforated with 1.4 millimeter diameter holes to remove larger particles. In order to reduce the loss of good fibers, the rejected portion is diluted with water and passed to a special final stage, the combi sorter, where these contaminants are discharged from the system, virtually free of fibers. Any heavy contaminants reaching the combi sorter are removed by a high consistency cleaner in a side stream. In the following multi-stage cleaner system, centrifugal force is again used. Very small, heavy contaminants, above all sand, are removed here. The next process stage takes out predominantly cube-shaped contaminants by passing the stock through screen baskets with fine slotted openings. Stickies are particularly critical contaminants. Various kinds of glues, as used for instance on envelopes and stick-on notes, are the main causes of stickies. The screen baskets have a slot width of 0.2 millimeters and remove the majority of these sticky substances. The next process stage is called flotation, the heart of every de-inking system. Printing inks, which have been detached from the fibers in the pulping drum, are removed here. The ink particles, ranging from 5 to 500 microns in size, are so small they cannot be screened out by mechanical means like other contaminants. Air is induced into the stock with the eco-cell diffuser and rises to the surface in the flotation cell tank. The printing ink particles attach themselves to the air bubbles and can thus be removed from the system. Some of the fillers and coating particles originally used in producing the paper are also removed at this point. The ink-laden black foam drops over a weir into a collecting channel, where it is deaerated and pumped to a secondary flotation stage. To achieve a high efficiency, the stock is aerated several times over again, resulting in a visibly higher brightness. Stickies, which are still present in small amounts, require an additional screening stage at low consistency. The slot width of the screen baskets used is 0.15 millimeters, slightly smaller than the previous ones. The flotation process only removes printing ink particles, which are freely floating in the fiber stock. To remove any remaining printing ink from the fibers, the large amount of water in the stock must first be reduced. The first dewatering machine, called a disc filter, removes over 90% of the water. The stock is fed into a large trough in which several perforated discs are rotating. The fibers attach themselves to the discs, while the water passes through the discs into a center shaft for reuse in the process. In the following screw press, the stock is thickened up further to a fiber content of approximately 30%. The fibers can now be dispersed in order to detach any printing inks still adhering to them. At the same time, the size of any remaining stickies is reduced. The stock is uniformly conveyed by a screw conveyor to the disperger. Here, the stock is first heated by steam to soften any remaining sticky substances and to make the fibers more flexible. The stock is then forced between a fixed and a rotating toothed disc, generating intense fiber-to-fiber friction, which detaches the remaining ink particles from the fibers. The disperger is also ideal for mixing bleaching additives into the stock if a higher brightness is required. In this case, the stock is fed by a screw conveyor into the bleach tower. The optimum bleaching result is achieved after approximately 1 hour retention time in the tower. The crumbly stock is then made pulpable again by rediluting with water. Using the same principle as in the first flotation stage, any remaining freely floating ink particles are now removed in a second flotation stage. This provides a further small increase in stock brightness. For standard de-inking applications, the process normally ends at this point, with the stock stored in a storage tower. Since it would not be economical to store the stock at low stock consistency, it is once again dewatered using a disc filter. Where a very high paper brightness is required, additional bleaching agents are mixed into the stock ahead of a bleaching pipe prior to storage. A de-inking system not only consists of the machines in the main process line. Equally important are the areas of water management and rejects and sludge handling. And without competent process, instrumentation, and control engineering, no system can operate reliably. Voith has proven solutions for all these areas. The competence is reflected in over 30 complete de-inking systems, which Voith has engineered and started up just in the last 6 years. Voith, engineered reliability.